My name is Nathan. This is JC, or Joe. We're going to be talking, as was just stated, about persistence mechanisms on ESXi. So our comments today are going to focus a lot on post-exploit. So assuming access, how do we maintain that access when we gain access to an ESXi hypervisor server? But before we roll into that too far, we'll get into a little bit of introductions. Joe?
All right. Hey, thanks, Nathan. Hey, good morning, good afternoon, everyone. We're going to be doing a little bit of a hand off the mic here, dance for a few times back and forth, so just bear with us. So yeah, I'm Joe. Some of you may know me as JC or Crashwire. A little bit about myself. I'm a cyber threat analyst professionally, hacking hobbyist, really enjoy it. Once avid CTF player, I don't do it so much anymore, but periodically you still see me mess around with things like Hack the Box or whatever, and also just eternal student. I'm always trying to learn, figure out new things, so that's kind of what I try to embody. And here's Nathan.
Thanks, appreciate it. Appreciate it, Joe. Hey, everybody. Yeah, my name is Nathan. Some may know me as Wham. I would actually be surprised if there's too many in the audience. I'm also a cyber threat analyst, a USAFA Delusions of Grandeur alum. I think we got at least one more here. And former offensive cyber ops for the Air Force. Did that for a couple of years before coming over to a company called Valley Cyber, where we're focusing on Linux and hypervisor security type stuff. Also have a podcast called Rob Lobsters. Check it out sometime. We talk about cybersecurity current events. But you don't really care about that too much today. Let's get into what we're going to be talking about in this specific presentation. So first, talk a little bit about hypervisors. Probably going to be preaching to the choir on that one. Then why we focus on ESXi as the specific hypervisor that we're going to be thinking about how to achieve persistence on. Then a little bit about some of the APTs that have leveraged some of the techniques that we're going to be using today. And then we're going to get into the actual persistence methods, and I promise that will be the fun part. So we'll get to actually see some of the technical demonstrations of these happening against real ESXi servers. So this will include using local.sh, the local profile as well, and then getting into service creation, though this one will be non-persistent, and then Symlink hijacking, so trying to take over some of the commonly used binaries on ESXi, and then to gain full persistence totally across reboots, we're going to use a malicious VIB, and we'll talk more about that close to the end. So the first thing is hypervisors. So again, you probably know what they are. It's really just an efficient use of computing hardware, right? Now, unfortunately, the end result of this for attackers is that it's also a really efficient target. Hypervisors become super juicy because if you're virtualizing, half of your workload on just a couple of pieces of hardware, just a couple of boxes, if you gain access to those, then suddenly your impact can be pretty devastating, especially for ransomware actors, right? This is where we see a lot of folks going after hypervisors is in that as well. So yeah, they're super important, a little bit annoying to manage sometimes, but as long as they're working well, then usually we're not paying too much attention to them. And that's going to be kind of one of the themes of what we talk about here today as well, is using some of the administration portals that people typically use with them sometimes doesn't give us the fine-grained access we need to really monitor what is happening on hypervisors, especially like ESXi. So let's get into some of the facts about them, right? So why ESXi specifically? Largely because it makes up a huge portion of the market, at least in kind of more enterprise level organizations, right? We see a lot of ESXi usage. It's derived from Linux. And so there's going to be a lot of familiarity for attackers typically when they're targeting an ESXi hypervisor. Usually when you're bringing over custom-built malware or something like that, you don't even have to really do much porting, right? A lot of it will run straight out of the box on an ESXi machine if it runs on like x86 Linux, right? Again, significant blast radius of compromise because we're doing that centralization. Hey, do you want your entire infrastructure encrypted, or would you like to pay to unencrypt that? That's often the question that people get asked after a ransomware attack actually occurs against an ESXi host. And then there's a little bit, I'm hesitant to really say this one when we talk about it being difficult to secure, but it's just typically not something that we think about securing. This is really a lack of attention. So folks are just not paying as much attention historically to their hypervisors. They're viewed as an appliance, kind of set and forget, maybe do a little bit of virtualized workload management, but not too much day-to-day administration, especially at the maybe like the CLI level.
Sometimes an order of years between what the attackers are doing, and finally by the time it takes defenders to catch up. So over the past 3 years, we've seen a pretty significant increase in attacks targeting VMware infrastructure, specifically vCenter and ESXi. And what that usually tends to be is like ransomware actors, right? They're trying to get in, they're trying to find a way to have that quick access to the hypervisor so they can encrypt all the VMs. But an interesting trend we're starting to see lately is now APTs are starting to target that infrastructure a little bit more recently as well. So UNC 3886, what kind of tools are they using? Well, like we said, they're using a lot. but we're going to focus kind of on two for this talk a little bit. And these are the two that we derived some of the tactics and built off some of the tactics from as well. So the first one's, it's called Virtual Pi. It's a Python backdoor C2 agent. And what this utilizes is something called a malicious vSphere installation bundle, or VIB. And Nathan's going to talk a little bit more about what VIBs are. But they use that to achieve persistence on the hypervisor, ensuring that that these backdoors and these implants are going to survive a system reboot, which we're going to see is going to be kind of a catchy thing that we have to deal with a couple of these payloads, that only a handful of our payloads are actually going to be able to survive a reboot. The other thing they use is something called virtual PITA, and that's just a ELF kind of a shell script backdoor that's going to create a listener on a hard-coded port. Now this has been discovered to establish persistence via using a service from the ETSI init.d services. And one of the tactics that they do that we're also going to kind of do, it's really simplistic, right? It's kind of that security by obscurity, is that they're just going to name these backdoors or these services something that either does already kind of exist on the ESXi host, so it doesn't look odd or out of place to an admin, or they'll just name it something that looks like it might fit in there, like VM tools support or something of that nature. And that kind of goes back to the whole point of why this is getting targeted is not that it's necessarily hard to secure, it's just not focused on. So admins don't know what looks out of place when they just see something that's called VMware fill in the blank. So we'll do a little bit about that here shortly. And I'll hand this over to you for your one slide.
Yeah, this one we probably shouldn't have flip-flopped so much. So this is just to give you guys a quick look at some of the persistence methods that we're going to use. I'm going to give it right back to Joe to go over the first couple. The thing that I want to highlight here, two things really, is one, we're going to be doing living off the land, right? We're not going to be bringing in a lot of custom binaries, with the exception of the malicious VIB. You could kind of quantify that way, I guess, but it really is still a VMware supported tool. The other thing I want to highlight is that far right column with the MITRE attack mapping. So the reason that this is important is because many of you are probably familiar. In April of this year, MITRE attack version 17 was released, and this has become enough of a problem that MITRE decided to make an entire framework, an entire matrix, in the attack framework rather, to address ESXi specifically. This included a few new techniques as well as the porting over of a bunch of other ones. And so what we've done is we've kind of tried to take probably the most predominant of those techniques from that framework and associate it with each one of the persistence methods that we're going to be using. So I won't go through this exhaustively, but just to kind of give you guys a brief view of that up front. And I'll give it back to Joe to jump into our first one, the local.sh script.
Thank you. Yep. All right, boot time. Okay, so yeah, exactly what Nathan was saying. We're going to start kind of the simplest payloads, just using the system against itself, and then we're going to get a little bit more advanced at the very end. But it's shockingly simple how some of these tactics, or how, it's shocking how simple some of these tactics actually are. So the first thing we're going to focus on is something called local.sh. Now this is a shell script that's just going to run automatically at the end of the boot process. Now this is the tool, it's designed to function this way, right? Why it's there is it's going to allow administrators to configure their custom commands to execute after the hypervisor has booted and initialized all the system services. For this specific payload, the drawback to it is because the tool is meant to do that. Think of like kind of cron. Everyone knows that attackers like to use cron, so cron jobs are one of the first places that a defender is going to look. Similar thing with local.sh, right? It's very, very visible. Like Kanye, you can see it coming from a mile away, which means that it's easily discovered. Another drawback to this one, and kind of a catch, is if you have secure boot disabled, local.sh isn't going to, it's not going to actually fire off. So from an attacker perspective, if you land in a hypervisor, you gain your initial access, you start enumerating around, and you find out secure boot's enabled, it probably isn't a good tactic for you to use. So how is it supposed to work, right? So when the ESXi host is initialized or rebooted, the boot initialization on power up, it's going to load the kernel, boot bank, it's going to mount the RAM disk, and start all the services like host E, HTTP proxy, and all that kind of stuff. When it goes through all that list, once the end of the network services are up, ESXi is then going to source local.sh from ETSI RC local.d. And you'll see, like we talked about earlier, virtual PITA, that's where they're putting one of those binaries is RC local.d. So they're using that file path we've already seen, like APTs utilizing that. This time we're just writing directly to local.sh. One thing to consider, if you are on the attacker side and you're doing this stuff, like red teaming or whatever, is that output is typically going to be logged to a number of different files. So if stealth is a consideration, make sure you know where you're getting logged. And then finally, once local.sh is completed, the system's going to finish booting and become fully operational. So we'll demonstrate that right here. Just to kind of explain what we have here. We're just going to say, okay, we have initial access. We've already landed on the hypervisor we've compromised SSH creds. So we SSH into the box. That's going to be the screen on the left, and the screen on the right is where we're going to catch our shell. So over here, I'm already on the box. I just CD right over to RC local.d. You list that out, and you're going to see whatever scripts the admin may put in there. We're just going to focus on local.sh specifically. And it actually says it in there. There's warnings like modify this at your own risk. You know, don't use the secure boots enabled. So it's kind of just giving us the keys of the kingdom right away. So we're going to go down there. We're going to kind of get rid of our little exit thing here. And we're going to just dump a quick payload in there. And kind of what Nathan was talking about earlier, using living off the land binaries. Anytime we're importing malware onto a system, if there is any sort of, and yeah, we're going to, sorry, before I skip ahead, we're going to use a port 8000 because by default that's just always on ESXi. So we go ahead and have our listener on port 8000. We pass our uname TAC age to show when we land on the host and pop that shell. And then you could reboot the system, but that would obviously flag some indicators, take some time. You can just run the script directly from RC local.d, and then you have your reverse shell. So we kind of went through the payload itself pretty fast. None of these payloads are going to be very complex. We're kind of just keeping these simple as a proof of concept. But what we really want you guys to focus on is that, you know, once again, we're not porting any kind of malware. We're not using any like advanced tools. We're using netcat, you know, because that comes default on ESXi for whatever fucking reason they put it on there. So you can just write a quick bash script, have a netcat listener ready to go, and then there you go. Netcat is on ESXi, and you get your reverse shell. So yeah, nothing brain busting, but that's how easy it is to start establishing your persistence. So that's kind of level 1, right? Level 2, so now we're going to talk about login shells, specifically on profile.local. This is going to be very, very similar to local.sh, but instead this is going to be focused on a user interactive shell. So when a user is going to log into the ESXi host via an interactive shell, right, so not like a DCUI or a vCenter login, the user modifiable script profile.local, which is in the etc folder, is going to be sourced. Now, this is commonly used for custom shell environments, you know, variables and scripts, similar kind of thing, right? It's an administrative tool. Significant drawback in our payload here is that the attacker session is going to be directly tied to the existing shell session that you have. So if the user, for whatever reason, they terminate their shell session, well then, you know, your agent then is going to drop and it's going to get killed. Similar to local.sh, this won't get executed if secure boot is enabled. Now, one of the differences between the two of these in local.sh, and I kind of skipped over it, is local.sh, that's going to run as, you know, root context. The difference with this one is that this is going to be, your context of your shell is going to be dependent on whatever that user is that's logged in. Now, the caveat there being is, if you're logging in on SSH on an ESXi hypervisor, odds are you're going to be root user. So it's kind of a moot point that you're going to have at least some type of elevated privileges, because normally admins aren't going to be going and giving regular users access to the hypervisors. So we'll go over this one, same kind of setup as before. We're going to have our listener on the right-hand side. We're going to go into the etc directory here. Listed out, you can see profile local at the bottom, and we'll just use our favorite text editor, VI, to write to that. And same thing, just a bash script, netcat, have our listener ready to go. And once we write to that, the difference here being is we'll write this, activate our listener, you know, we'll pass our rename TAC A. But instead of just executing it right from there, we're going to demonstrate, we're going to say, okay, you know, somehow our session terminates, or, you know, we want the user to log in. So now we're just going to simulate that the administrator is coming in, doing his business, and this is kind of a victim-activated payload, or, you know, a tripwire payload, if you will. Once they log in, the profile.local file will get sourced, and then that just triggers our reverse shell right there. And then you can, we can list out and see what folder we're in. But cool. So that's profile.local. I will now pass it over to Nathan for the next payloads. There you go.
All right, great. So next up is service creation. So this is kind of one level further, right? So now what we're going to do is, instead of associating something with some of the login scripts with a specific user or just with the machine in general, we're going to be talking about kind of getting more at the operating system level and treating this like a service. The reason we do this, and the reason this is maybe a step further, is because it makes it a little bit harder to track, right? It's not going to be obvious. It's not going to be the, you know, local.sh file that we know Broadcom wants us to use for making modifications persistently. Instead, we're going to be using something that is typically reserved for legitimate services. So we're going to do this by making a new script in etc init.d. We're going to make a couple modifications to it just to ensure that it actually executes. And then what we would typically do if we were going to try and make this persist across a reboot is we'd also edit the rc local.d directory and the local.sh that is in there to ensure that the service actually gets run. Since we're not installing this legitimately, that's typically the thing that we're going to do. So that would persist, right? The local.sh. The big drawback of this is that although it is more stealthy and we can get it to run in one boot, we're going to sound like a broken record by the end of this presentation, because all except for one or two of our methods here across the reboot is not going to persist, right? So that etc init.d, the actual service script itself, because of the volatile file system on ESXi, is not going to persist. But we're going to make it just use the same syntax that we would expect in any other service script that we see on ESXi or Linux. So without further ado, I'm going to jump into this one. Again, we got kind of a similar thing. We're also going to use a slightly different payload on this one. So we're going to ask our service that we're going to create here to actually use OpenSSL, and we're going to use OpenSSL as the communication. So instead of just using a netcat session for this one, to make things a little bit harder to track for a defender, we're going to use encrypted traffic over OpenSSL. So we'll go through that here as well in a second. But what we're doing right now is we've got a new service script that we're copying into the init.d directory. So you'll see here again, it's just got our OpenSSL client command is what it's running. So it's going to be using that OpenSSL binary to make the connection. And we're going to have to generate a cert over here on the right hand side on our attacker machine as well. But before we do that, we're going to run a chmod plus x on our vmtd script. We're going to name it vmtd to make it look like it actually belongs there, to make sure that it's actually executable. And then, let's see here. Oh yeah, we're going to make the edit to the profile, the local profile as well really quick. So again, this one, we're not actually going to end up using this because we're not going to do a reboot for this particular method. But in a situation where you were able to make the service script actually persist, which we'll demonstrate here in a minute, that would be how you would end up calling that service, since we're not installing it legitimately. So you can see all it's doing is it's calling that vmtd script that we just created in etc init.d. So we're going to make that one executable as well. And then we're going to go back into our init.d directory so that we can call the script pretty easily here in just a second. So we are going to call it directly in this particular one, just to show you what it would look like if we were going across reboots. So now we're going to generate that OpenSSL cert really quick. Give it just a sec. Yeah, we're just breezing through all of the associated metadata for that. And then we're going to actually start the server. So that's the next thing that we're going to accomplish here. So we'll start the server, open it up again, port 8000. And then we're going to prime it with our classic uname tag a command. And then what we're also going to do is we're going to run a quick little Python script to upgrade to a PTY to make our session a little bit more usable, a little bit more user friendly for us once we gain it. So you'll see that's just we're importing the PTY library, and then we're spawning a new PTY with a bin sh, which actually is not really sh. It's actually just like a busybox binary that we pretend is sh, but that's fine. That's just how ESXi is. Okay, so now we came back over onto the left-hand side. We manually called vmtd in this instance, and we can see, hey, there's our PTY to that Python script that we got over there on the right side. So this is a cool one because, again, it makes this just a little bit more stealthy, but again, it still suffers from the reboot problem, right? So now we're going to start getting into a couple of techniques that may help with that reboot problem a little bit. Specifically when we get into the VIBs, that's going to be a thing. But you can see here now we're just running a couple of commands to verify that our connection is working. But I'm going to go ahead and move on to the next one to save us a little bit of time here. I'm going to turn it back over to Joe. We're going to talk about the Symlink hijack method, and then we'll move into VIBs.
Okay, cool. So Symlink hijacking. For those of you unfamiliar, right, in Linux or Linux adjacent systems, Symlink or a symbolic link is just a type of file that acts as a pointer or shortcut to another file or directory. So you can see that in our ls out on the right of the screen, kind of the arrows pointing to another binary or another file path. That's just saying when you call the binary on the left, it's simply just going to execute whatever exists there on the right. So kind of what Nathan was saying, if you look at lower down on the list, a lot of the stuff that's actually going on kind of behind underneath the hood in ESXi is going to be busybox binaries. But for this purpose, we're going to focus on something a little different. So Symlink hijacking, right? When an attacker manipulates this file path, they can point it to the original Symlink to like an attacker controlled binary or maybe another file or something of that nature. All you're doing is just kind of redirecting what you're calling. This works particularly well on ESXi due to the fact that if admins are utilizing that shell access, they're going to be using tools like esxcli to manage the hypervisor itself, right? And as you can see up on the top right, esxcli is just a Python script that we're going to point to something different. Now we could try to modify that script itself, but the problem is when you have that state.tgz, if you can't kind of manipulate that, you're sort of locked in those binaries. So writing these protected binaries in the bin directory is challenging. A way to get around that is instead of rewriting it, you can just write your own, right? We're kind of doing this living off the land stuff. Python, once again, natively exists on the ESXi host. So we're going to go ahead and utilize that, and root execution is going to be the context we're utilizing. So, okay, Symlink hijacking, it's nothing new, so what? What's different this time? Well, we're going to kind of repurpose it a little bit different, right? Traditionally, what Symlink hijacking is used for are things like overwriting files or maybe like changing permissions, privilege escalation. But here what we're going to do is we're actually going to redirect the execution by replacing that original binary esxcli with a symlink to our backdoor wrapper or shell. So this is another example of victim activated persistence, or that tripwire method. So anytime an admin goes in, they're going to utilize esxcli to do whatever, system maintenance or some updates or something of that nature. That's going to trigger our backdoor. And how it's going to do is it's first just going to say, go ahead and pass the command that you would as usual, and then detach and just pipe it over to our malicious shell and access that in the background. So we'll go ahead and we'll demonstrate that one right now. So the first thing that we're going to do is we're just going to kind of demonstrate what it looks like. An admin may go in, esxcli, they're going to say system version get, and you're just going to get some version information, right? And now we're just going to do a series of copying and moving files and symlinking that's going to allow us to hijack this stuff. So the first thing we're going to do is just take that original Python binary that esxcli is pointing it to. We're just going to copy that over to something called esxcli original, so we can restore later if we want to. Now we're going to write a binary that we're just going to call something random, right? VMware check. Sounds legitimate, right? It's a simple Python script. All it's doing is it's just saying, hey, initially go ahead, run the initial esxcli binary, and then you're going to fork and detach the follow-on reverse shell so that the admin has no idea what's kind of going on quietly in the background. And that's going to be our Python script that we're going to point anytime esxcli is activated. So we're going to make that executable with our chmodx. Once we do that, then we're going to move the actual esxcli binary out of there and replace it with this VMware check. So we move that binary. Sorry I don't type faster, folks. You wouldn't have to listen to me talk so much. We'll move the esxcli, move that over to binary. We'll just call this like esxcli backup or something. And then finally, just a simple one-liner. You just link tac s, and that's your symlink. So we're just going to say link that VMware check binary to esxcli. And once that's complete, we can activate our little netcat listener just to catch our shell. And now we're listening on that port 8000, pass the rename tac a so we can see when our shell pops up. And now we're just going to do the same command that we did the first time, esxcli system version get, and something different is going to happen this time. You still get the same information, no delay, but now we have that reverse shell. So it's quietly, all it's doing is if there's already a connection, it's not going to try to execute that shell, but if there isn't an existing connection, we're then going to get that reverse shell back to our host. So that's Symlink hijacking, but just kind of redirecting the output. This is a cool kind of like little easy backdoor hidden method, but like really unlike, or excuse me, like all the other ones with the exception of local.sh, this is another one that it's not going to persist through a reboot. So in the event the admin goes in and they reboot, you're going to lose that symlink. You're going to kind of have to go in and do it again. So you get persistence to a degree, right? And now we're finally going to culminate with the malicious VIB, and we're going to tie all these methods together. We've been building off of them, and now we're going to do something where we're going to bring them, a lot of these all together. And Nathan will talk about that one.
Thank you. All right, folks, now we're into my favorite one, the malicious VIB. I'm sure you've all been waiting for it. So what is a VIB? It's a vSphere installation bundle. This is really just a glorified zip archive. That's really all it is. But it's one that can be signed by VMware so that we can have different levels of support, right? So we can have like community supported, which means just me, Joe Schmo, made the VIB and wants to install on your ESXi host, all the way up through, like a VMware created one or VMware signed or VMware supported VIB. So there's these different levels that we have for VIB acceptance, but they do require, cryptographic keys and also the cooperation of VMware to have those escalated ones. So what we're going to be doing today is a community created one. So we're going to use the lowest level of acceptance. And typically, this is actually something that I'm a little bit proud of that we're going to be able to show you here today. Typically, when you have secure boot enabled on ESXi, one of our favorite hardening techniques, you can't change the acceptance level. So it will not let you change the acceptance level of whatever VIB it is you're trying to install. So community supported, if we don't have that in the acceptance level, then we're not going to be able to install it. Unfortunately, there are ways around this, and we're going to demonstrate this here in just a second, using only some of the utilities that are extant on ESXi. So we've talked about this a lot. It's an ephemeral file system. It's volatile, right? So there's a couple of exceptions to that, like mounted data stores and the like, where the VMs actually reside. Unfortunately, this has been used in recent attacks, which you can kind of see from some of those headlines there on the right. So what we're going to do with this one is we're not only going to use a VIB, we're also going to try and obfuscate our traffic one more level by using DNS. So what we have is a little homebrew. It's quick and dirty. I promise it's nothing too crazy. But we have a little homebrew DNS client that we have that that's actually what we're going to install using this VIB. It's just going to be consistently called as a service. So harkening back to what we were talking about before, where we edited the service scripts within esxcli init.d, we're going to do that, but this time we're going to use a VIB to do it. So the reason we can get away with this is because the whole point of a VIB is that it gets added to the state.tgz file, so the actual encrypted file that gets unpacked every time the ESXi boots up. So a VIB gets reinstalled every time the ESXi system boots. This lets us make actual persistent changes to the file system or to services and have those be there every time we restart the machine. So this is probably your most reliable method if you want true persistence on an ESXi machine post-exploit. So yeah, we're gonna create that VIB. I'm actually gonna do that part off screen. We're gonna create the VIB with the C2 agent. We're gonna have the VIB ready to go. We're gonna then log into the ESXi box. We're gonna alter that acceptance level first thing, and then we're gonna install the malicious VIB, run the C2 server over on the other side, and then we're gonna have arbitrary, command execution. So you guys will get to see that just very briefly there. Before we jump into it, here's just a couple of the things that you need to understand before we are actually able to execute this attack. So one is the descriptor XML for VIB creation. This is where we do a couple of the things like, hey, whether or not reboot is actually required for the VIB to fully install, which is just we can edit that because we're the VIB creator. The other thing over on the other side, I have to give a little bit of credit to Kaushik Lathia and also to Austin Gading over at Valley Cyber for helping us kind of do some of the research on that. But if you dive down through the host image.py scripts within some of the ESXi utilities, there's actually a couple of ways that we can do some manipulation by making a custom acceptance.json file and then manually uploading that and updating the configuration on ESXi. So although trying to do it through esxcli is not allowed, we can use a couple other commands to try and accomplish the same thing. Okay, so we're going to dive into this one really quick. So here's our ESXi, just web UI in the background. We're not really going to pay too much attention to this. It's just to kind of show you that it's there. And then I'm going to begin by SCPing over my host BG, right? That's what I've named this one, hostbg.vib. So we SCP'd it over. Now I'm going to go ahead and SSH back into our ESXi host. Once on, we're going to run uname again just to verify that we're there, make sure that it's what we expect it to be. So we see it's our ESXi host 7.0.3, a little bit of an older version, but hey, the codes check out, right? So the next thing we're going to do is we're going to change that acceptance level. Now, I'll pause here just for a minute so that we can kind of take a look at that. What you can see we're doing is we're just creating an acceptance.json file, and then we're running that config store cli, config current set. It's kind of a complicated command, right? But if you dig through those Python files, you can find the right arguments that are actually going to allow us to update this, even with secure boot still enabled on the ESXi host, which is what we're doing there. Okay, I'm going to go ahead and hit play there. Now you've listened to me yap about it. Okay, so the next thing that we're going to do is we're going to try and install the VIB just right off the bat. Now, unfortunately, because we haven't done any kind of cryptographic check in this, we just made this one homebrew, it's actually not going to pass extensibility checks. And oh no, that's a bad day, right? Well, actually, if you see what I did, we just add attack F, we force it to do it, and then esxcli is happy to install this non-extensible VIB for me. So you're going to see that pop up here in just a second. It takes it a minute because it's got to do a little bit of configuration and updating of that state.tgz archive that we're holding a lot of the stuff in, but we can see that executed successfully, no reboot required, and it's in there as bootbank hosty BG, right? So I move really fast through this part, so I'm going to pause one more time. I didn't name these things very sneaky things, but this is arbitrary, right? So I've got my threat runner script that's actually executing my service, and then we have the ex3 script that's actually that payload that I installed there before. And we can see just by doing a quick PS that simply by installing the VIB, it is already running. And we can verify that now by, oops, that wasn't good. Let's do this. There we go. Skip forward just a little bit more. Okay, there's our PS. Okay, so what I did over here is we're just going to start TCP dumping port 53, and you can see it, these commands right here, that txt cmd.test.local, that's our DNS traffic coming over to the DNS server that I'm running on my attacker machine from our service on ESXi. So now what I can do is I can prep it with a little command. You can see it's repeatedly doing that, right? So we're getting that test command all the time. We could make this a lot quieter if we really wanted to, but for demonstration purposes, this is how it's currently configured. Okay, so what we're going to do is we're going to try and just really quickly create a file as a proof of concept. It's just going to be a little text file that says hey in it, and then we're going to verify that it's there. Yeah, sorry, you guys have to watch me type too. we're going to verify that it's there. It's just going to go into Scratch, test. And again, this is, you could do anything, right? You could run whatever command you want. This is just to verify that something happened. And there we can see I'm trying to highlight the actual, not encrypted, but obfuscated DNS traffic that we have going across. And we can see that the shell that we have there is actually piping it a standard out, our command that we ran over to it. And now if we try and cat that out, we successfully created the file on ESXi. So this is a big news for us. We're happy to see that. And at this point, because I know that my command execution is working, I can do something bad, right? So that's why I'm just going to prep up this, hey, something bad.sh script. Could be anything. Doesn't really matter what it is for our purposes. We have persistence and we have that code execution. You can again see that obfuscated traffic going across the wire there. So thanks for bearing with us through that. We're gonna wrap it up. Joe, I'm gonna let you take this wrap up slide really quick.
Cool. All right, thank you. Yeah, so just kind of recapitulate everything that we just talked about, right? The reason why attackers and red teamers or whatnot need that persistence is honestly initial access can be lost pretty easily. You could have an unstable exploit or something, credentials in your environment may change, the environment itself may change, maybe an admin adds an MFA solution or something like that. So that's why these attackers, right when they get in there, they're like an octopus. They're just spreading out their tentacles in like all sorts of different places that they can. They're trying to just really grip into that environment and ensure that like you cannot remove them. So when you're doing this kind of stuff, we believe redundancy is good. We showed like 5 or so different kind of payloads you can use, ranging from very, very easy to maybe a little bit more complicated. But combining all these together or doing all of them at the same time or having that multi-payload approach really is the way to go if you want to establish that really significant persistence in that environment. And the reason why we wanted to do living off the land tools or what formerly known as like fileless malware, things like that, is that these attacks, they're the past, they're the present, and they're the future. They're not going anywhere. So instead of trying to like run all these known malware signatures, you can just use those tools very simply that exist on the host against itself, and you can do very devastating effects. So yeah, that's kind of our talk. We stood on the shoulders of a lot of other much smarter people than us. So shout out to the guys over at Signia, Google Mandiant, some of the folks at Valley Cyber that really helped us kind of throughout this process, as well as obviously the folks over at MITRE. And yeah, if you want to get in touch with us, you can find us at any one of these links, and you're going to have to ask Nathan for his OnlyFans.
I'm not giving that one out either.
Yeah, so. But cool. That's about our time. If we have any questions, we'd love to answer them. Otherwise, we'll pass it back. Thank you.
Thank you guys.